Hey, Michael Church here with Crawl Space Ninja. I have a very, very special guest with me today. This is Bruce Snead from Kansas State University, and Bruce is the person in charge of the radon courses and different things like that at Kansas State. And I'm gonna have him tell you about what he does. But I learned about Bruce by watching some EPA videos through the Environmental Protection Agency, and reached out to him, and he was kind enough to join me today on this call. So take it away, Bruce. Tell us a little bit about yourself.
Sure. Well, thanks for having me, Michael. I appreciate the invitation and the time that we're spending together to help educate folks about radon. Bruce Snead, I'm Director of Engineering Extension at Kansas State University, and I've been here actually for 40 years. We have had radon programs since the late 80s, doing initially one of the originally funded EPA regional radon training centers. So we've been doing that for 30 plus years. We've been providing services to the Kansas Radon Program through the State Indoor Radon Grant EPA funding under contract, and we provide technical assistance as well nationally under a cooperative agreement with the US EPA, and have so since 2009. We have 5 hotlines that we answer daily from people across the country. We have a website that provides access to information, and we provide technical assistance to states. We provide training under contract of various state radon programs. And we have a radon chamber, one of 2 secondary approved NRPP certified radon chambers, providing spiking, device performance tests, device evaluation, and we do calibration for the EcoSense Radon Eye Pro. That is one continuous radon monitor that we calibrate. I have 5 other folks that work with me here at Kansas State in the radon team. And so we have a multitude of activities, but our primary goal is to help educate the public, industry, federal agencies, EPA's cooperative partners about radon, and provide access to information so people can make informed decisions regarding radon. I'm an architect by my training and background, but really I'm a building scientist and adult educator, and have been for many years here at Kansas State University.
Well, Bruce, again, I appreciate you being here. A lot of people don't know, but the Crawl Space Ninja was started on the foundation of indoor air quality, and that led us to looking specifically at crawl spaces and how they affect indoor air quality. And we dabble in basements, and we've done some attics and different videos like that. But radon, in my opinion, is one of those things that it's not well known on how to address it properly in the crawl space. Even those that seem to be certified in radon mitigation tend to do it incorrectly. And that's why I wanted to have you on board. This is information that I feel like all homeowners across the country should know about, no matter what state you live in, versus me just giving my opinion about what's happening in Tennessee or some of the areas that we cover. So again, thank you very much. I appreciate that introduction, and you may be the most qualified person I've ever had
Well,
on our videos.
I certainly know enough to be dangerous,
Yeah, that's right,
and have provided training and outreach to just virtually all manner of audiences. So hopefully I can help folks with accurate information about radon.
Well, thank you. Well, first of all, if you don't mind sharing with us, what is radon and where does it come from? If you don't mind sharing that with us.
Sure. Radon is this unique, naturally occurring radioactive gas that comes from the radioactive decay of uranium and radium, heavy metals that are in the Earth's soils and crust everywhere in greater or lesser concentration. It's a fundamental atomic element. It's on the periodic table of the elements. So it is, but because it is odorless, tasteless, colorless, naturally occurring, no man-made sources, it comes from the geology of the Earth, the uranium and radium as a process of radioactive decay. And it is a unique environmental health risk in that it increases through long-term chronic exposure our potential for developing lung cancer by exposing our lungs to radioactive emissions that can cause DNA, physical or chemical damage, leading to cells dying, preparing themselves, or mutating and replicating. So radon produces these radioactive emissions that can damage our lungs. And when we breathe radon, what it decays into, what are called radon decay products, they can lodge in our lungs, and these emissions can cause change. And so that's it. We're concerned about radon because it's the second leading cause of lung cancer, #1 among non-smokers. It's estimated that 21,000 people every year die from radon-induced lung cancer. Smoking obviously is the #1 cause of lung cancer, but radon's #2. And if we look at the list of cancer causing cancer deaths, radon is #8. Radon-induced lung
Wow.
cancer is #8 in the list of all cancer-induced death, sources of cancer death. So it's a very significant health risk. And it's a very challenging health risk because odorless, tasteless, colorless, naturally occurring, chronic long-term issues, not immediate response or symptoms from breathing radon and being exposed to radon. So we are clueless in terms of our perceptual systems and what it does to us. And so it is without question for me been the most challenging topic to provide education and adult education on, because of the complexity of what it is, what it does to us, the various disciplines that go into understanding those aspects of radon, those different dimensions and concepts associated with radon, and its radiation, which is just in and of itself is a non-intuitive topic and concept for the public. We are exposed to radiation. We live in a world of naturally occurring radiation. We have exposure to medical radiation for diagnostic and treatment purposes. We all know about nuclear power plants. We all know about the nuclear bombs. And so we have this gamut of radiation, but this is a unique, naturally occurring source of radiation that has this one particular health risk associated with it that is deadly and is naturally occurring. If it was man-made, radon would have been regulated long ago. But because it is naturally occurring and it's everywhere in greater or lesser concentrations, our government has taken an administrative or educational approach to it. Now, some states have enacted legislation relative to certification or licensure of those who test or fix, and require testing at schools or other types of facilities. But it is, because it is a non-regulatory approach, at least in terms of estimating of requiring action on the federal government, it's an administrative and educational approach that the government has taken.
So
long answer.
well, no, that you hit on many different points, and I just wanted to be clear. So unlike, say, me walking into a smoky bar or a smoky house, I have no idea when I walk into a home that there's radon. Is that basically right? Like if I walk into a smoky bar, I'm like coughing, or my eyes are watering or something like that. Right. So radon is completely different.
Yeah, it does. I mean, you're exactly right. You walk into a smoke-filled room, you have a reaction to that, driven by your own personal perceptions and history and sensory load. Radon doesn't cause any of that. And so the only way to know the radon level anywhere is to test. We can't predict radon levels based on building age, structure, foundation type, the materials, the heating and ventilating system. Radon is everywhere. The only way to know the radon level anywhere is to test. And that's why the Surgeon General has recommended that all homes be tested, right? It doesn't matter whether it has a basement or a crawl space or a slab on grade or a combination of those. The only way to know is to test.
Okay. The other thing is as far as what you said, I believe that the longer I'm exposed to it, just like most indoor air pollution, the more likely it is to affect me. So if I walk in 5 minutes, probably not that big of a deal, but the longer I'm exposed, years, are we talking about years or months, or what are we talking about?
Yes, it's a chronic long-term risk. Lung cancer doesn't occur in 5, 10, 15, 25, 30-year-olds. Typically it's 45, 55, 65, 70-year-olds is where lung cancer is manifested or is detected in terms of the age groups. And so it is a chronic long-term risk. We're most concerned about the radon level in your own home because that's where you spend the most time indoors, right? Typically. And so that's the place to test, because even if you are a radon mitigator and a radon measurement contractor or work in crawl spaces like you do, yes, you can have on the job exposures, occupational exposures, but in almost all cases, the radon level in your own home is more significant because you spend more time there.
Right.
So our exposures are a result of the time and the concentration where we spend that time.
Okay, so another, I'm going to get into testing here in just a minute, but again, I want to talk about the importance of knowing, or the importance of why you should know about radon. You mentioned it's the #2 cause of lung cancer, and I personally have had family members that never smoked ever that developed lung cancer. I can't go back and prove that it was radon, but I mean that's probably the most likely candidate for that would be radon exposure. Is that right?
Sure. We have people that are never smokers that get lung cancer. And while it doesn't matter, whatever the lung, if you get lung cancer, we cannot prove that that lung cancer was specifically caused by smoking, radon, passive smoke, or other carcinogens that someone may have been exposed to. We don't have that quote smoking gun, but what we have is human stories and human studies that have identified radon as a significant factor in the development of lung cancer. We have the epidemiological studies of minors. We have case control studies in residential settings from across the United States and across the globe. And overwhelmingly, the statistical significance of these studies points to radon as a Class A known human carcinogen that increases our potential for developing lung cancer, and nothing else. Smoking and radon are multiplicative in risk because of what's in the smoke, chemicals, other forms of radiation. So those things interact and are actually multiplicative. So if you smoke and your radon exposure, it multiplies the risk for lung cancer.
I got you. So let's talk about building structure just for a minute, because you mentioned schools. Obviously, we're going to talk about crawl spaces, but one of the things that I'd like to know is, let's say I work in a high rise or in a building, or maybe I've got a 3 or 4 story home. Is the higher I get away from the ground, the less I am as far as risk goes to radon? So for example, the basement would be more risk, or does the stack effect actually carry the radon all the way up through the building?
Well, the answer to that question is something I've used a lot in my work in radon. That is, sometimes, maybe, it depends. Okay. In typical residential structures, we tend to find the highest concentrations in the lowest space. If there's a basement, we tend to find the highest concentrations there, and it's likely that radon levels will reduce as you move up through the house. The highest concentrations there because it's closest to the source, which is the soil underneath the foundation. Okay. Radon doesn't settle out of the air by gravity and collect in the basement. That's a myth, right? Radon is higher in the basement typically because it's closest to the source that's coming in. As we move up through the house, outdoor air that's infiltrating, which is lower in radon concentration than what comes out of the soil, tends to dilute that. And so let's say, well, in my own home, the basement measures 4.1 picocuries per liter. The first floor measures 2.1, and the second floor measures 1.2, and those are year-long average radon concentrations. So that's a common distribution. Now, if your basement is 40, your main floor might be 20, and your top floor might be 5 or 10. It all depends on that infiltration rate and the source strength that's coming in to the basement. We don't tend to find higher radon levels as we move up through a structure and a multiple or high rise. But the exception to that is, for example, if, and we've seen this in the Southeast United States, high-rise condominiums made of concrete using aggregate that contains uranium and radium in it. In other words, the foundry of the quarry where the aggregate is used to form the concrete. So at the 17th floor of a 20-story high-rise, we've got 6 picocuries per liter of radon because it's emanating from the concrete surfaces. Now, this is, again, the exception rather than the rule. The source here, isn't coming from the soil underneath the building. The source is in the building materials itself, which is not likely, but with granite, which may contain uranium and radium, or concrete, which is made with aggregates that may contain them, there is this potential there, but it is not the primary concern. The primary concern is radon coming out of the soil into our buildings. But we have seen examples where radon has been moved or pushed or pulled by elevators, which act as a piston in a building, right? What is an elevator? It goes up and down, pushing air up, coming down, it can pull. So it creates pressure differentials that can move radon from the elevator shaft or adjacent utility or basement spaces and push it up into upper floors.
Okay.
So understanding the dynamics of how buildings work and what causes air pressure differentials and movement of air can help us understand why radon is what it is, where we measure it.
Okay. And you had mentioned picocuries per liter. I'm sure everyone would like for you to kind of briefly explain
Sure.
what that means. And also, you mentioned levels. What's the acceptable EPA levels for
Sure.
radon? Of course, no radon is acceptable. Is that correct? But
Well,
they have to set.
since it's in outdoor air as well, we can't escape from radon. There are no concentrations that are zero. Outdoor air is about 0.4 picocuries per liter of air, and picocuries per liter is a measure of radioactivity in a liter volume of air. 1 picocurie per liter is actually 2.22 disintegrations, radioactive emissions per minute in a liter of air. Radon, the National Action Guideline or level is 4 picocuries per liter. Okay, and that's what, when you're engaged in real estate transactions, houses are tested by home inspectors and others. That's the number that the issue is resolved around. Is it 4 or more? Then mitigation is recommended. If it's less than 4, it's not that it's safe, but that it's, again, below this EPA guideline, which functions as a de facto standard.
Right.
In terms of real estate transactions. This is the number everyone relates to. So, but it's not just fundamentally, the difference between 4.0 and 3.9 is not statistically significant, right? I mean, the number is the number, and that's why we want accurate measurements to base our decisions on. But yeah, there's no safe level of radon, and we'd like it as low as reasonably achievable.
Okay.
And that's the good news. When you test high, your home can have a mitigation system installed that many times will get the radon down below 2 and sometimes even below 1 picocurie per liter, which is excellent performance for radon mitigation systems.
Okay. And let's talk about testing, if you don't mind.
Yeah.
What are some of those testing methodologies? What do you feel is the best? You know, I know you're actually your university is constantly testing monitoring systems. So and they have to be calibrated. That's important as well. So
Right.
is a DIY test that you send to the lab the best way to go, or a continuous monitoring system?
Well, part of it has to do with cost. You can purchase single-use radon test kits, either short-term, 2 to 5 days, 7 days, or longer term, 3 months to 1 year, that give you one number for the period of deployment and gives you the average radon concentration. Those are going to cost $15, $20, $25, $30, $40 a piece for a single piece of information. Continuous radon monitors come in 2 categories. One is for professional use, folks like yourself that are maybe certified that want to use continuous radon monitors that have demonstrated their accuracy by being evaluated through a device evaluation program, through the National Radon Safety Board or the National Radon Proficiency Program. And we've done those kinds of evaluations of devices here at the KSU Radon Chamber. That means those are, quote, more, I would say, more reliable because they have demonstrated their accuracy in an evaluation program. The continuous radon monitors, and that this applies both to the single-use test kit types of devices as well as the continuous radon monitors. There is another category of monitor called a consumer digital radon monitor. These are devices that typically cost $100 to $300 or in that price range, and these tend to give more frequent. Obviously, they are more continuous in the information they give. They may be designed to give you an average result for every 7 days. They may have the capacity to even give hourly results, but they are not what we call, they have not gone through a device evaluation program to demonstrate that they are accurate. I'm not saying they're not, but they haven't gone through the specific steps to achieve a listed status for use by professionals in making recommended decisions. But when people want to know we live in a world of what? Cell phones, instant access to information, instant answers. We don't want to wait. And having a digital monitor enables people to get more current information about the radon levels in their home. So that's kind of what's available. The devices that are available to the public from laboratories and manufacturers, single-use test kits have all achieved a listed status and are appropriate if you read and follow the directions, deploy it according to the instructions with the test kit or device, and the purpose of the test in your own home. So yes, all of these devices that are available to the public generally, either the single-use devices, if you use them properly, can give you reliable results. Calibration involves continuous radon monitors used by professionals. That has to be done annually. So that means the device is exposed and adjusted based on readings from being in a radon chamber and additional other technical factors that may need to be evaluated. The consumer digital monitors do not generally get calibrated because homeowners are just not likely to do that. And it may in fact cost as much to get a consumer digital monitor calibrated as to buy it. So that's not likely to happen based on our experience and having dealt. We have a fact sheet that addresses these consumer digital radon monitors to help people understand what they are, what they provide, and how to interpret the results that they get. The good news is there's lots of ways to test for radon, options available online, and different types of test kits. But if you read and follow the directions, use them properly, you're good to go.
Okay, so how often should our homes be tested, and is testing during the real estate transactions recommended?
Yeah, always during a real estate transaction. Anytime you buy a property, a structure, a house, we recommend testing. Even if it's got a radon mitigation system, it should be tested, right? And so yes, and there are states like Kansas, where I'm at, that require tests and real estate transactions to be done by certified individuals. So you need to be aware of the state regulations or requiring certification or licensure and who can do what. But yes, always in a real estate transaction, you want to have a radon test as part of a home inspection, if that's what if that's what you engage in. If you have tested your home and it tests low, and nothing changes, maybe once every 5 years, it would be appropriate. But if something significant changes after you've done the initial test that gives you low results, like you changed your heating and cooling system, went to a higher efficiency furnace, you weatherized your home, blew insulation in the walls, or swapped out all your windows with more high efficiency, well-sealed windows, or you add on to your home with a new foundation area, or addition to the home, an adjacent crawl space or slab on grade addition. If you do any kind of base foundation work, in other words, you have a waterproofing system installed, or you cut holes in the basement slab to put in bathroom fixtures or something like that. Those are the kinds, and you have what we would call foundation events, right?
Right.
If you have flooding, if you have something else that may change the pathways through the foundation or the pathways in the soil that connect to the foundation, enabling new pathways for radon to migrate or move through, opening up. So that's a quick listing of why you might want to do another test after these kinds of events or conditions occur.
Perhaps crawl space encapsulation could also affect that, correct?
Sure,
Especially
sure,
if you're sealing up all the vents.
absolutely. Yeah, if you do anything to change the relationship, the air pressure relationships that the house and its dynamic function exert on the soil, it would be logical to test again. Crawl space encapsulation would be good to test ahead of time to know. If you test before you renovate the basement, for example, the radon level, then you can maybe able to take steps during that renovation to address the radon concentration more economically.
Right.
And so I would see the same thing in terms of crawl space encapsulation and significant change in ground cover or ventilation related to a crawl space.
Okay. When I'm testing a crawl space, or the homeowner's testing a crawl space, do you recommend the testing happen in the crawl space itself or the floor above the crawl space?
Not if the owner doesn't live in the crawl space, we don't recommend testing there. And now, I used to say you never test in the crawl space because nobody lives there. And one time I was looking online in San Francisco and at the San Francisco newspaper, and there was an advertisement for a crawl space to rent for $500 a month.
Really?
So yeah. I mean, what crawl spaces are like, and I'm sure there are most of them you would not want to live in. Anyways, so that's why I always say there's always these exceptions, but nonetheless, you don't live in the crawl space, so don't test in the crawl space. Test in the living area above the crawl space because that's where the exposures are. Now, you working in a crawl space, for example, if you're in crawl spaces 5 days a week, it might be good to know what the radon levels are where you're going to spend 8 hours doing an encapsulation project, right? It's really a confined space type of activity. And so it would be good to know if the crawl space was 200 picocuries per liter and you're going to work in it for 8 hours, you're going to want to ventilate that crawl space. Now, again, the only way to do that is to have some kind of a sniffing device or other monitor that would give you a clue about that relative radon concentration. But we don't test in crawl spaces unless it's a diagnostic test, for example, what I just described, to help you better understand where source strength might be or something like that. But we're concerned with where people are in terms of conducting tests. Everything outside that realm, if we took soil samples and measured radon or measured in the crawl space, are kind of diagnostic tests to help us understand how the house works and what we might need to do in terms of mitigation.
Well, I'm pretty excited because you just gave us another unique selling point to crawl space encapsulations. We can start renting them out in short-term rentals on Airbnb and Verbo. So thank you for sharing that with us, Bruce.
I'll be really interested to see the low-level furnishings that you use.
All right, that's right. All right, so let me ask you this too. We don't let me forget about discussing active ventilation and how Crawl Space Ninja does that. But one of the other things that comes up is normally your mold remediators. It's unethical for them also to be the testers. Is that the same in the radon? I don't know why only mold people are called out for that sort of thing, but in the radon industry, is that also a rule of thumb where the person checking for radon cannot be the one doing the installation of the radon mitigation?
Sure, really good question. And we see the gamut. For example, in Illinois, which is a licensure and certification state, you can't test and then fix what you've tested, okay? Right. And ethically, there is that possibility that if someone tested and fixed it, mitigated it, that there could be fraud or deception. I would have to say that broadly reviewed in the decades I've been associated with the radon industry, we just don't see evidence of that. Have there been exceptions and examples? Yes, but it's rare. It's just like any other home service industry, right? When a HVAC contractor comes in, he diagnoses your furnace, says you have a cracked heat exchanger, I can fix it. Your plumber comes in, does the same thing. Your electrician comes in, does the same thing. Why should radon be any different? Only thing is, radon, odorless, tasteless, colorless, natural occurring. We need black boxes and monitors to tell us the levels. So is there a perception that perhaps deception or fraud might be going on? But I just believe, based on having trained thousands of radon measurement and mitigation contractors over the decades, that people want to do a good job. People get into the radon industry and the radon community because they want to help people avoid lung cancer. That's the bottom line. And so while association with professional associations or industry organizations may have ethical codes of conduct and ethical rules that could say you shouldn't test and fix, it depends. And I just simply say, we want people to test and get their radon levels reduced. And if you live in Western Kansas, where there are only 6 or 8 different measurement and mitigation contractors serving half a state, they need to be able to do both. And we want them to sustain their business in that way. So anytime you use a radon contractor, measurement or mitigation contractor, you should be a wise consumer, ask for references. Are they certified? Have they taken training, passed an exam? Are they voluntarily certified if they're in a state that doesn't require certification? If they're in a state that does, are they listed with that state? So those are the kinds of things that I think help protect the public in terms of dealing with radon in their home.
Okay. Many years ago, I believe it was called the EPA Indoor Air Plus program when it comes to crawl space encapsulation. And they talked about a calculation of moving air outside of the crawl space at 1 CFM for every 50 square feet. Now, this has nothing to do with the radon mitigation system. This is just good practices to ensure that the crawl space does not build up soil gases. Is that still something the EPA recommends today?
I don't know that EPA has taken that particular position. In my experience with building science and foundation design, used to be that crawl spaces were always vented. You would always vent the crawl space with the kind of guidelines you just talked about. How much square foot area or square inch free area of vent do we need per square area of the crawl space? what we've learned through energy efficiency and weatherization is that having a crawl space with floor insulation and venting underneath perhaps is not as effective or as efficient a crawl space as perimeter insulation. In other words, where's the thermal envelope of the building? Is it the perimeter foundation or is it the floor over the crawl space? And of course, you throw climate factors into this. What's it like in Florida, Louisiana, Missouri, Montana, Michigan? Has different implications for ventilation and impact of ventilation in a crawl space, right? Ground and source humidity and temperature of air coming in. All of these things have created I think, a perspective about crawl space insulation and structure, leading to it's probably better to have perimeter insulated crawl spaces than floor level insulated crawl spaces. And vapor barriers and the vapor retarders, certainly, and their value is important, not only in terms of moisture, but also in terms of soil gas.
Right, right. Okay, so what makes up what we call, or I believe what the EPA calls, a submembrane radon mitigation system?
Sure.
What does that typically look like?
Okay, well, the goal is in a crawl space, open dirt, we want to put down a membrane that will help trap the radon that's coming out of the soil beneath the membrane, seal it to the perimeter of the foundation, seal it where there are penetrations for structural columns or mechanical systems or piping. And then we pull a vacuum or suction underneath that membrane with a continuously operating fan. So we penetrate the membrane with a sealed 3 or 4 inch diameter pipe, run perforated pipe out underneath the membrane to extend the vacuum effect of the fan, then run the pipe up through the house or up and outside the house to a fan, and then discharge above the roof. So a submembrane depressurization system sucks the radon from beneath a well-sealed membrane in the crawl space and vents the gases into the air above the house. It's the same as a slab on grade or a basement style, except here we have a plastic membrane or a membrane material instead of a layer of concrete that we're exerting our vacuum underneath.
Okay, now there are some manufacturers of these vapor retarders that claim that their retarder is a radon vapor barrier or radon plastic. Is that?
Sure.
I think that's a little misleading, because I think it allows people to think that if they throw plastic in their crawl space, it'll stop radon. I believe the EPA still requires the fans and all that as part of that. Is that correct?
One of the things that I need to kind of correct here is that EPA has certain policies related to standards and mitigation and measurement. EPA produced the initial protocols and radon mitigation standards back in the 90s. Since then, in around 2000 and after, the standards that guide our work and EPA recognizes now are the AARST ANSI standards. That stands for American Association of Radon Scientists and Technologists, American National Standards Institute. And AARST is a standard setting ANSI recognized standard setting consortium. So EPA no longer has these standards. Now, that said, certain states, when they adopted certification or licensure, did so when the EPA standards were available. And so they may still be in effect. And that's why I say you have to check with your state to see what, if any, requirements there are for what people do in measurement and mitigation. But EPA, if you go to their website, recommends the use of these AARST ANSI standards that affect single family, multifamily, large buildings, measurement, mitigation, radon resistant new construction. So there are standards available that address proper experienced based approaches to measuring and fixing and building radon resistant in these building types. So I think that's important to share, because a lot of folks say, well, EPA does this or EPA does that. No, they've pulled back from that standards setting stuff, and it's now through voluntary private organization that is accredited and a consensus based standard. So in other words, it's not like 3 guys sitting in and having a beer figuring things out. It's a committee of folks that come together regularly that debate these issues, debate the text, debate single words. I can share from personal experience ad nauseum to try and get the best possible standard out there that everyone can relate to. Okay. So that's important, I think, to understand. Now, as I said, you should always look to your state radon program for any guidance they have, or if they have specific standards or regulations that they've adopted. So we need to be, I think, cognizant of that.
Let's talk about the is it ANSI standards? Is that what you said?
Yeah, American National Standards Institute, AARST, ANSI standards.
Okay, so again, I'm going back to what the EPA standards was that I read and all that, but they recommend certain products, the EPA does, like polyurethane caulks versus other types. Is that still the case today, or are there other sealants that are allowed in radon?
Well, in the standards themselves, there may be ASTM standards that are referred to, for example, for membranes, for other kinds of materials, piping types, etc. So the new AARST ANSI standards have addressed these issues of materials and specifications of materials, referencing codes and things like that. So that's what I would refer to, and I don't have all those in my head to share with you, but that is now what folks should look for. And so the use of specific caulking materials is not such that you're going to say you must use polyurethane or you must use silicone, but you want to use something that it will function. For example, sump lids. If you secure a sump lid to the floor with polyurethane or other more strong adhesives, you may not be able to remove the lid without breaking it. So using silicone or gasketing material is what's recommended, so that the sump lid can be removed for servicing the sump pump. Gotcha. So that's the kind of issue. If you're going to do a caulk a floor wall joint, you want to use something that will be permanent and bond to concrete. Now, it doesn't have to be polyurethane, but obviously you're concerned with adhesion, with off-gassing and curing, and will that present issues, odor issues, etc. So a lot of these issues have been addressed, and recommendations are there. So there are shalls and there are shoulds, and there's recommended practices in these standards that can help any measurement or mitigation contractor understand what makes sense to use and do.
Will a fastener like a masonry nail or a Christmas tree fastener be helpful? Because I've been in crawl spaces where they only use a sealant for plastic, and over the years that sealant stops sealing, and then the plastic starts to fall off the wall. So are these fasteners also recommended in conjunction with the sealers? It's
always ideal to have both mechanical and chemical bonds, right? If you can bond the membrane to the sidewall, if you can secure it in place with a furring strip and nail gun or other mounting mechanisms, it's, you know, if you've got smooth concrete walls, you know, it's easy, right? Because if they're clean and clear, you can seal it, you can use batten strips. If you've got a limestone irregular foundation, right, it may be much more challenging to seal to that perimeter foundation wall. You may need to actually mount a furring strip, secure the membrane to that, and actually fill with foam sealants behind the bat, the furring strip, to fill those gaps where the in the rock and stone behind the furring strip. So you have to be flexible in crawl space work, because you're bonding to different kinds of foundation materials. Very good, very good. Thank you for sharing that. What are some of the major problems that you see crawl space specific radon mitigation contractors doing that you really have to point out for them to stop doing? What are some of the things that you see? Making sure you have a durable enough membrane for the application. And if the membrane is going to be a place where people crawl over to service HVAC systems, or there's going to be storage of stuff on top of it, the membrane needs to be protected so that it doesn't get abused over time. People have to service equipment and, you know, utility systems in there. You probably want to put some maybe carpet strips down or some fiberboard or something to protect that membrane. You need to label the membrane with what it is. It's a radon reduction system component. So there should be a label on the membrane. When people open the crawl space door, there should be a label probably on the crawl space door. It says membrane inside is a radon radon mitigation component. Do not violate its integrity. So labeling is important. In addition, getting pressure airflow from underneath the membrane is another important factor. And you can do that by, when you penetrate the membrane, have a T fitting underneath where the pipe comes down through the membrane in a sealed penetration, and then put perforated pipe out from the T fittings, the upside down T fitting underneath the membrane to extend the fan's vacuum pressure out further into the membrane, underneath the membrane. Now, if the crawl space is flat and has a smooth, kind of a very smooth surface, this could be very important. If it's very irregular, if it's a hilly crawl space with lots of gaps and cracks and things like that, it may not be as necessary. But we've seen cases where the membrane has been sucked down over the T fitting, the openings, which obviously will reduce the air being sucked from underneath the membrane. Right. It blocks the airflow. So you want to make sure that you can get what we call the pressure field of the fan extended out under the membrane itself. And so those are some things that are of concern and important in terms of installation, and the standards address these issues.
So the more smooth the soil, let's say I got a bunch of clay and it's super smooth, that radon mitigation system could become clogged by the vapor barrier, versus if the vapor barrier or the vapor retarder was on, say, an aggregate like gravel. Is that correct?
It's entirely possible. Yeah, the more permeable the soil materials, the more irregular the soil materials, probably the easier it is for the pressure to be extended. The flatter, and again, it depends on how much air you're moving, right? How big a fan, what's the capacity of the fan, how much air do you have to move to get full pressure field extension underneath the complete footprint or ground cover of the membrane.
Okay. Now, I think I know the answer to this when it comes to a real estate transaction, especially in some of these heavy regulated states like Illinois and Maine and places like that. But do you recommend radon mitigation to be performed by the DIYer or the homeowner? I'm guessing they wouldn't be allowed to do that during a real estate transaction, but
well, you can, of course, you can do anything you want to your own castle typically, right? In a real estate transaction, we recommend independent measurement, independent mitigation, and the standards speak to what folks should say and do, and what recommendations they should make in these conditions. But obviously, state regulations can play a role here as well. So in terms of DIY, do-it-yourselfers, I've worked with many over the years, and there are folks that can do this. But fundamentally, the key choice in radon mitigation is, what size fan do I need to fix this house? How much air at what pressures will effectively suck the radon from beneath the footprint of the house, right? And that's not something a typical DIYer understands. Pressure field extension diagnostics, right? To size the fan. The fan is not selected based on square footage of the house, radon level of the house, how old the house is, what kind of heating and cooling system it is, what kind of building materials it's made of, how airtight it is, or how leaky it is. It's based on whether or not we can extend the suction effect, the vacuum effect of the fan under the footprint of the foundation, whether it's a membrane in a crawl space, a basement slab, or a slab on grade. And that's something that can be determined by taking measurements of air pressure differentials. How much is the house exerting suction on the soil itself? That's something the fan has to overcome, caused by the stack effect, by wind effect, by venting effect of the HVAC system and exhaust appliances and exhaust fans in bathrooms and kitchens. These things operate intermittently and extract air from the house, cause air to move. So the fan has to overcome that. It also has to overcome the resistance of the foundation zone materials. You talked about clay, gravel, sand. Each of these have different resistance that the fan has to work against to pull from the footprint. And then finally, we have the piping system through which the fan has to push and pull air from the foundation zone up and through the piping system and out above the roof. So those are the resistances that the fan has to work against, and we can measure those. And then by looking at them and measuring them and estimating them, we can go to fan charts that talk about fan performance capacities with airflow and static and pressure that they create, and see if we can pick a fan that will do the job at the least cost and the least long-term operating cost. Wow. I know that's real quick, kind of, without pictures, discussion of diagnostics, but that's the bottom line. So that's not commonly something a do-it-yourselfer can do. They don't have micromanometers to measure pressure differentials from inside to the soil conditions, or from inside to outside, or in the piping systems. or airflow measurement to see how much air the fan is moving. So DIY tends to fall to folks that are just going to go buy a radon fan from a large building supply manufacturer or building supply warehouse and use it. Whether it's the right fan, whether it will work or not, it's kind of a crapshoot.
Right. Don't know until after you install it and check the radon, right?
Yeah, right.
Right.
There are in radon mitigation, there are folks that can do diagnostics and understand the importance of diagnostics, and then there's folks we call poke and hopers. Poke a hole in the soil, poke a hole in the slab, run the pipe, put a fan on it, and hope it works, right? And maybe it does, but that's not a energy efficient, nor cost efficient way to approach radon mitigation. We can size systems and select fans that will reduce the radon effectively at a least cost for electricity for the fan and reduce costs of the heating and cooling penalties associated with the fan. The fan may pull air out of the house because of leaks and gaps and cracks in the membrane or in the basement itself, the floor, the slab. And if we pull air out of the house versus radon out of the soil, we have a heating and cooling penalty because that air has to be replaced by infiltration of outdoor air. So we want to be efficient, seal as much as possible. So we suck radon out of the soil, not air out of the house.
Okay. And finally, if someone's looking to get certified, obviously KSU has those certifications available. How does somebody get in contact with you all to do that?
Sure. If at a certain point, if I can share my screen, I can share our websites.
Absolutely. And I'll put a link to all this down in our description below too, so someone can click on it. But yeah, go right ahead and do that.
Okay. Right. You should be seeing now the Kansas State Radon Programs website list. So these are the 4 websites that we use to drive our radon programs. The KSU Radon Chamber is for the industry. Those are seeking spiking of devices, device performance tests, etc. National Radon Program Service, sosradon.org, is our national technical assistance website that has the most information. The Kansas Radon Program is one we have for our state indoor radon grant with Kansas. It has also lots of good information, but is one that's state specific. So there's lists of certified individuals that are required to be certified in Kansas listed there, as well as much more. And then finally, radoncourses.com is our training website. This is where our webinars are in person and our online measurement and mitigation and radon resistant new construction, other kinds of continuing education radon content courses can be found. We have, as I said, we provided radon training for nationally for many years, and we have entry-level measurement and mitigation courses that serve both the voluntary National Radon Proficiency Programs, the National Radon Safety Board and the National Radon Proficiency Program. These are 2 voluntary national proficiency programs that in order to achieve a nationally listed or certified status, you take training, take an exam, then apply and pay fees and comply with certification and licensure requirements. So those are voluntary national level programs, and we serve those. In addition, as I said, there are states, probably about 20 nationally, that have some form of certification or licensure requirements. May be specific to the state, or it may just be you must be nationally certified by NRSB or NRPP. And so those, it just depends for each state as to what they require and when they require it. So you can find information about states, all the different states, at our sosradon.org website. We have a state contact listing. You can click on the map and see who is the contact phone number, website. And then we have state fact sheets as well. If you want to know more about the state and the legislation that may be required or have been passed, there are fact sheets you can download there as well.
And one last thing, I know this about the state of Tennessee where I'm located, that our state actually gives out free radon test kits to homeowners. So check with your local state if they do that as well. So
absolutely. Different states, especially sometimes in January, which is National Radon Action Month, we buy 5,000 tests. They buy 5,000 test kits and make them available free. Tennessee has done this for numerous years. And so, yeah, take advantage of the state radon program information, and folks like yourself that are in the radon industry and radon community should be aware of the state radon program and communicate with them. By you doing radon mitigation, you're achieving risk reduction. The state program is not going to get risk reduction if we don't have an active industry out there testing, fixing, and building radon resistance. So I want to salute you for the work that you do that reduces the risk of radon-induced lung cancer for your clients and your customers. And we're all in this together. It's a radon community and a radon family from my perspective, because the people that I've met in this industry, in this community, share at the bottom line, share a commitment to dealing with this unique environmental health risk and helping people have healthier homes.
There you go. Well, thank you, Bruce. And listen, I just want to thank all of you for watching. And like I said, I'm going to have all this information down in our description. If you need to get in touch with Kansas State University, that would be great. And I'm Michael Church with Bruce Snead from Kansas State. We hope you make it a happy and blessed day, and we'll see you later.
Thank you, Michael.